So in this case, we are going to consider a typical exam revision, which is an important part of our revision as we are preparing for the March exams. We have got a common test that we are going to consider. March 2025 exam where we are given that was out of 102 hours, which is we are going to see according to the question paper that we are given. That is for the KZN province. So when you are working with these questions, just try to do as many as you can because they are different provinces. They do ask sometimes like the layout of the questions can be differently given. So just do revise as many questions as you can. And also make sure that you go through your instructions, especially your answers. They are supposed to be given to 2 decimal places unless stated otherwise. So that is what you must consider. Given question number 1, we are where we are having our basics of our number patterns. Question number 1, question number 2. So like I said before, it's going also to depend with your province. Sometimes they will give you questions which are based on what? Which are based on algebra. It can be like that. You have to answer according to what you're given. And also for you to be able to download this question paper, check in the comment section, or you can check the description of the video or on the description of the channel. Just go through the grade 12 folder where you can download all the question papers that are there on the drive. So question number 1, without wasting our time, 1.1 we're given the sum of n terms. All right, so there we must be very careful of what we are given. It is the sum of n terms of an arithmetic what sequence. So they gave us the presentation for the sum of terms, just like Tn, the way that we are used for the nth term. But this time it's not for the terms, it is what? For the sum, Sn. So we must be able to differentiate between the two. The sum of terms, simplified. Now on 1.11, calculate the sum of the first 21 terms of this sequence, the one that you're given above. So we are already given the number of terms and the given expression is for the sum of terms. So we're just going to substitute 21 in place of what? In place of n, as n is equal to what? 21. So the sum of the first 21 terms from our Sn, we have to substitute n 21 in place of n. So that's 3. In place of n, we have got what? 21, but that is supposed to be what? Squared. Minus 5 times our n. In place of n, we substitute what? 21. So this is what we are given. Simplifying this, we are going to obtain as 21, the sum of the first 21 terms. That is, you can just use your calculator here. 3 into 21 squared. All right, that's minus 5 into 21. You simplify this. That was going to give us 1,218. So we've got 1,218 as the sum of the first 21 terms. Given 1.12, determine the 22nd, the term of the what? This sequence. All right, so take note. This is the term. This is the term that we must determine, not the sum. It is to determine T22. So the question is, how can we determine the term from an expression which represents the sum of terms? But this is for the sum. From Sn, how do we find Tn? All right, remember, I referred before, that's 1.12, that if we are given Sn, all right, given Sn it therefore follows that Tn is equal to Sn minus Sn minus 1, which simply tells us that when we are given the value of n to determine for t, that is, for an example, t 22, as we are given there, that's t 22. Our n is 22. So that must be S22 minus the S of what? Our n is 22. So that's 22 minus 1, which is going to give us what? 21. So we must have S21. So that's the sum of the first 22 terms minus the sum of the first 21 terms, of which we have S21. Remember, we simplify that one. So we must determine S22. From where? From our Sn that we are given as 3n squared minus 5n. Let's determine S22. So from our Sn, which is given as 3n squared minus 5n, let's determine S22. In place of n, you are going to put 22 there. So that's 22 squared minus 5 times 22. So you're going to simplify this just like what we had before. In place of 21, let's just put 22. Here, let us also put 22. So that was going to give us 1,342. 1,342 as the sum of the first 22 terms. With the formula here, we can simply substitute the sum of the first 22 terms. So that's to obtain our T22. So we have got this one, which is what? 1,342 minus the sum of the first 21 terms, which you calculated from the first question here, 1.11, which is what? Which is this one. So that is how you can simply attempt this type of a question. So that is the basics of our sum of terms to determine the nth term from what? From the sum of terms. So finding the difference, this was going to give us 124 as the difference. So that's our T22. So you can be given any term from the sum of terms, just substitute in this manner, Sn minus what? S of n minus 1. So that is it on 1.12. Moving on to 1.13, where we are given how many terms of this sequence. How many terms of this sequence? Which sequence are you talking about? The arithmetic sequence must be added. So when I talk about adding, this is what? Sum. Sum of, must sum up to, give us this, must be added to obtain a sum of. So what are we dealing with? Sum of terms must be added. These terms were being added together, so they are representing the sum of terms, not Tn, but from our Sn. We are simply saying, in this case, these two, they must be equal. Remember, our Sn is given as what? 3n squared minus 5n. And the same Sn, in this case, the sum when all these terms are added is 8,162. So these two, they must be equal. So we can determine the number of terms, which is n. How can we determine that? These two, they represent the same thing. So therefore, the algebraic expression representing 3n squared minus 5n must be equal to the numerical value that we are given as 8,162. This is a quadratic equation. So remember, one side must be equal to 0. Ax squared plus bx plus c is equal to 0. So we're going to take this to the other side to obtain a 0 there. 3n squared minus 5n minus 8,162 is equal to 0. With this, we can solve our quadratic equation. So guys, we do understand this thing of factorization method, this and that. But when you've got complicated values like here, guys, if you check these values, they are very big, like the constant there. Just use your quadratic formula. So as we do understand our quadratic formula in terms of x, but in our case, we are dealing with n. So n is supposed to be equal to minus b plus or minus the square root of b squared minus 4ac everything over what? 2a. So we must determine our a, the coefficient of x squared. In this case, the coefficient of what? N squared. So our a is 3. B is the coefficient of n, which is negative 5. And our c is the constant, negative 8,162. So we can simply substitute into our formula to determine our n minus b, which is negative 5, plus or minus the square root of b squared. That's minus 5 squared minus 4 times our a, which is 3. And our c is what? Negative 8,162. Like that. Everything over what? 2 times a, which is 2 times 3. So we substituted the b in place of b. In this case, we have got our b in place of b and so on. So this is what you're going to have. This is our b, and where else we have got our a here, and this is our a, and our c, which is this one. So that is it. Simply use your calculator. Guys, there is no need of us simplifying further here, guys, already because of the number of marks here, 4 marks. This presentation alone is enough for you to just write your final answers. So simply use your calculator here. So that was going to be what? Put a fraction. So we have got a minus and a minus 5. So open a bracket for that. All right, we're going to start with a plus. All right, let's start with a plus. So that's plus the square root of what? Minus 5 squared. So put a bracket for that one. Minus 5, then we square it. Then minus 4 times 3. So just use the multiplication, or you can use the bracket. It's up to you. Times 3 times our c, which is negative. Put this negative inside the bracket. You guys, most of you guys, you use the minus this one. This is to subtract. This is the negative of a sign on a number. All right, this one on a bracket. So it's the one that I'm talking about there. So you're going to have that negative 8,162. All right, everything over what? 2 times 3. So 2 times 3. So that was going to give us 53 if we are dealing with a positive. So let's figure out the value of n when we have got a negative here. So you're going to just change. All right, sorry for that. We need... all right, so this one, it actually disappeared from what we had. But if we're going to put that negative, guys, it was going to give us negative 154 over what? Over 3. You're going to get something like this, of which we are referring to the number of terms which cannot be a negative, which cannot be a fraction. We are supposed to obtain positive whole numbers. So therefore, our n in this case is supposed to be what? 53. So that is the condition. They're asking us here to say, what is the condition? How many terms of this sequence must be added to obtain this? So we are talking about what? 53 terms must be added to obtain that. So therefore, 53 terms has to be added. All right, to obtain or to get what? The number that we are given, it was what? 8,162. So that's it. Those are the terms, 53 of them. You add them. So that is how you can simply answer these questions. Let's do revise as many questions as we can. All right, moving on to 1.2, where you are given to consider this sequence. All right, so let us see what type of a sequence is it. Looking into this, we can figure out something which is unusual. The 7, 7, 7, repeating 7, then 7. That 7 that we are seeing there, if we are to consider this, we can see that it is actually a combined sequence. Let's check properly. This condition of the 7, 7, which is the same 7 here, the same 7 here. Are we seeing that this is affecting the odd numbers as we are starting with what? With 1. This is T1, T2, this is T3, T4, T5, T6, T7, T8. So this is for the odd T1, T3, 5, and 7. Those are constants. So it is a combined sequence where there are constants for those odd terms. We are forming what? It is for the constants. The 7, 7, 7, 7, and so on. T1, T3, T5, and so on. Then there's another one which is remaining. Definitely is going to be for the even, 2, 4, 6. So the even, let's see what are we forming on the even. There is T2, which is 7 here. So that one we do not know, is it going to be arithmetic or what? So the 7, T4, which is 12, then T6, which is 17, T8, which is what? 22. So I talk about even numbers, 2, 4, 6, 8. So that is another sequence. So there are two sequences that are being combined together, all right? So the first one, we can see these are constants. Then here, checking properly, we can see that there is a common difference here of 5 here. 12 minus this, that's a 5, 22 minus this, that's a 5. So this one is an arithmetic. It is just important for you to just note what type of a sequence that you have, as there are two of them. Anyways, 1.21, determine the value of the 70th term of this sequence, T78. Okay, so T78 belongs to which of the two now? That is the question on 1.21. This is the question that you must ask yourself. T78. 78 represents what in terms of the numbers from the original sequence? When these numbers are being combined as they are, 78 is an even number, this one. We are talking about what? An even number on that 78. So if it is an even number, it means we are going to obtain it. This term, it is an even what? It is an even term. Under these terms that we are referring to as 2, 4, 6, 8, and so on and so on, we were going to have the T78 along those even numbers. But guys, if we consider it properly now to say, when these terms are put back here to form this arithmetic, there are now new terms of an arithmetic which you can consider as first term, second term, third term, fourth term. So T78, according to this arithmetic, is equivalent to what? Because this is for the combined, when both are combined together. But what about on that even term sequence that we form, the arithmetic sequence? Which position are we talking about? Because we are counting 2, 4, 6 when they are combined together, because there's 1, 2 that we had before. But this is for n. Let's get rid of this. These are single terms, T1, T2, T3, T4, T5, T6, for an arithmetic sequence. So it's going to be which position? We simply have to divide 72 divided by 2 to have the value which corresponds, which is what? Which is 39. So the T78 of the combined sequence corresponds to T39 of that arithmetic sequence, or of the even terms. Here we are talking about the even terms only, not a combined. Those even terms only, there must be 39 terms. So you must be very careful. So the even terms, This is what we have for our even terms. Remember, the even terms are the ones forming n arithmetic. So we are going to find Tn from there. Remember, that's arithmetic a plus n minus 1 times what times d, where a is the first term. So our Tn is going to be what? A. Here we are saying T2. So it has changed, guys. We took this one from the combined sequence. But as a sequence on its own, to say it is the sequence of the even terms, we are saying this is our T1, this is our T2, T3, this is our T4. This is the one that we are talking about to say T39 in that order. So our first term, 7 plus n minus 1 times d, which we can just substitute the n because we know that is 39 terms, all right? But anyways, that's also in your hands. Let us just find direct T 39 is going to be 7 plus, in place of n, that's 39 minus 1 times what? Times 5. So use your calculator here properly. That was going to give us the value of T 39. 7 plus, you can even simplify before substituting the 39. It's still one and the same. Then we multiply 5 here. This is going to give us what? 197. So this is 197. This is T39 for the what? For the even. This is what we are talking about, 197. But that is the same as T78 when it is a combined sequence, because on a combined sequence, that's where you're stating this as 246. So it will be corresponding on the 78 position. So this is one and the same thing. Here, it is according to the 39th position from where? From the even terms only. You're just considering the even terms, not as a combined sequence. Once you can understand this, guys, you will be able to answer any question under these combined sequences. Let's consider 1.22. Calculate the sum of the first 103 terms of this sequence when it is combined. So still, it is a combined there. 103, these are combined, just like they were combined. But we have to separate now to say for the even terms, how many? What is the n there for the even terms? It is the same thing here. These are combined terms. So we have to separate because here, remember, there are odd terms. There are also even terms. So we must separate that to say how many terms are there for the odd terms. So that is the first thing, to note the number of terms. So n is equal to what? You divide this one, 103 divided by what? By 2. Since this one is not an even number, it is going to give us what? A decimal. So this was going to give us 51,5. So as of the position, so if we are to consider now the position here, we are going to notice that for the odd numbers, so n, for the odd numbers, we round up. Since the odd numbers are the ones that are starting 1, 3, we start with a 1. So you round up. For the one that you start with odd numbers, you round up. So this is the sign of rounding up, 51,5. So if we round up, this is going to give us what? To the next digit, 52. So there are 52 terms. So meaning to say, for the even numbers, those are the ones that are remaining out of 100. 100 minus 52, or you just have to round it down. So this one does not affect when you are rounding down. It will just go back to the what? To the 51. So the sum of these is supposed to give us what? 103. So this is just to tell us, guys, how many terms are we actually dealing with in terms of odd, in terms of even. It was just like the previous question that we had. So these are terms separated, as there are two sequences that we consider. So therefore, in our case, to obtain the sum of the first 103 terms, we are going to add the sum of the first 52 odd terms. This is for the odd terms, which is those constants, and we add to the sum of the 51 terms, which is representing what? The even terms. This is what? For the even. All right. So once you can be able to separate these guys, we are done. Now you just have to figure out to say, what is it that you are referring to the odd? All right. As we can see, the odd, they are constants. How do you determine sum of terms when you have got constants? That is the case. So let us just have our sum for the first 52 terms for these odd. So as it is that we are dealing with what? With constants, it therefore follows that Sn for constants, it is that constant times the number of terms. So for 52, it is the constant, which is 7, times how many terms? 52, just like that. So that was going to give us the sum of 364. 364. Then for the even terms, remember the even terms are the ones that are forming what? An arithmetic, the ones that we have been working with here. So we are finding the sum for an arithmetic. That is what you're going to have for the even terms, since it is an arithmetic. Sn is equal to what? You can use the formula in your formula sheet. N is equal to n over 2 into 2a plus what? N minus 1 times d. You have got this part. All right, from our arithmetic, we can simply substitute what we are given there. So meaning to say, for the odd terms, we have got the constants, which is fine. Then for these even, how many are they? 51. So n is what? Is 51 for the even terms. So we're going to substitute in place of n. That's 51 over 2. All right, so this is 2a, which is 2 times our a. The first term, remember, on an arithmetic, we say it is what? It's 7. You substitute to the arithmetic there. So that is 7 plus n minus 1. The number of terms, they are 51, minus 1 times what? The difference, the common difference, remember, it is what? It is a 5 throughout. So this is the condition. So in this case, we were going to obtain the sum for the first 51 even terms. For the 51 even terms. So that is it, 51 over 2. All right, so there we're going to have over 2. That's into what? 2 times 7. So let us just have a bracket here. 2 times 7 plus n minus 1. That is 51 minus 1, of which you can just simplify direct, times what? Times 5. So that's it. This was going to give us 6,732. 6,700 and what? 32. So these calculations actually must be shown. You must indicate the calculation for this and also this one, of which you can even just combine them on your formula. If you do know that you're not going to have any mistake on your calculations, you can just simplify it direct, or you can simplify them separately. The even terms on their own, the odd terms here on their own. So that is it. So remember, this was an arithmetic. So with these two, combine them. We have got the sum now for the combined sequence. Everything is now combined. So those odd terms, remember, they added up to 364, plus the even terms, they added up to what? 6,700 and what? 32. So that was it. From there, we can obtain the sum of these 103 terms. So that was going to give us 7,000 and what? 96 as the sum of 103 terms combined together. It's a combined sequence. Separate If you can be able to separate like this, you're done. Knowing the number of terms, for odd, we just round up. Then the even, we round down, of which the even, if you now we have the odd, these ones, just subtract from what? From all the terms that you're given. There are 103. So subtract the 52. You obtain what? 51. So that is how these questions sometimes might be given as. You just have to work out as many questions as you can. Moving on to question 2, where we are given this part of a summation. All right, then question 2.2, it was quadratic. All right, let's see. The first part we are given, that's 2.1, given this summation. And as we can see, there is a number minus 3 raised to the exponent of k. That alone tells us that we are dealing with what? A geometric. This condition, guys, of an exponent. Talked about this, and that number is going to be what? Our common ratio, of which it's not a problem. Even if you cannot tell, you can just find the terms. So lucky enough on this question, they asked us on 2.11, write down the values of the first 3 terms of the series. The first 3 terms from the value of k, which is what? The lower value given there, which is 2. So when k is equal to 2, you substitute in place of k there. That was going to be minus 3 to the exponent of what? Of 2. So simplify this on your calculator. That's a positive 9. If you do not know, just use your calculator. To the exponent of 2, that's what? A positive 9. So we have got the first term, positive 9. So we are going to do the same thing for a condition where our k in this case moves on from 2, we add 1, so it's now k is what? Is 3. So you're going to raise this one to the exponent of 3. From your calculator, that was going to give you a negative what? 27. So you move on. When this k is equal to 4, you do the same, negative 3 to the exponent of 4. And that was going to give you positive what? Positive 81. So those are the first 3 terms that you're given. 2.12, write down the value of the constant ratio. So it is just telling us that we are dealing with geometric. If I have got these terms, I can simply use the terms. But like I said, by just looking into this, we can see that it is what? Minus 3. But let's say you do not know this, simply substitute. Our R is equal to a T2 over T1. So we can just substitute from the terms that we have, or you can use T3 over T2. So our T2 over T1, that's negative 27 over 9, which was going to give us what? Negative 3. 2.13, will this given series summation that we have here converge? This is the same as what we were given before, but now they're saying being taken to what? To infinity. For this geometric series to converge, the conditions that we do understand is R must be greater than negative 1, but less than 1 for it to converge. So in our case, already we have the numerical value of our R, which is negative 3. Is negative 3 in within the interval from minus 1 to 1? Do we have negative 3? Negative 3 is outside. That is where we have it. It is not in within this interval. It is less than minus 1, of which our R must be greater than minus 1. But in our case, we have R which is equal to minus 3. And thus, our R is less than. Here it must be greater than minus 1. But here minus 3 is what? Minus 3 is less than minus 1. So we cannot have this one as a convergent. No, because our R is less than 1. Besides, it must be greater than. So the series will not converge. The series will not converge. So the reason being what? Our r there is less than -1. Instead, it must be bigger than, it must be greater than. So this is how you can simply attempt these typical questions. All right, moving on to another question, which is 2.14. Calculate the value of this. All right, give your answer in terms of what? In terms of x. So they want us to simplify the whole summation from this part. So guys, this one is just a direct question because we can tell one about our r there, because what just happened here, guys, is that we are now having x as a product. So meaning to say, on those terms that we have as our T1, it is now given as 9x, this one minus 27x, this one is 81x. So is it going to change our R? This is not going to change because you put x here or in 27. So it's going to be minus 27x. And this will be 9x. So the x and the x still will cancel. So our common ratio, guys, is going to remain as before. There's nothing that is going to change on our common ratio. We are going to have the same as before. All right, so this is it here. If we are given the x value and the x value, still they will cancel. You have your -3. So our r is not going to change. What is going to change is our t1, because there will be x there instead. All right, there will be x in this case. So therefore, guys, as we know that we are dealing with a geometric, we do understand summation, sum of terms. So we go back to our geometric, all right, which is now referring to the sum of terms. We can simply use our formula in that manner. So this is the one that we are going to simply use a into what? R to the exponent of n minus 1 over what? R minus 1. Where our a is what? Is the first term, which is 9x, as they said in terms of x. So how many terms? From 2 to 3. How many terms do we have? So n, remember, the top minus the bottom, 13 minus 2, but we must add a 1. So that was going to give us 12, all right? So sorry for that. So this was going to give us what? This was going to give us a 12 as the number of what? As the number of what? As the number of terms. With these, we can substitute to say we are calculating the sum of the what? Of the first 12 terms, right? Let's put this one as it is. So this is 12 here, n is 12. So a, as we have got in terms of x, remember we said now we're going to have x here. So this is going to be 9x into what? Our r is not going to change. It is still the minus what? The -3. So that was going to be -3 to the exponent of n, which is 12, minus 1. All right, we subtract our 1 here over what? This whole part is over r minus 1, of which our r is what? Negative what? -3. So that's -3, -1. So simplify this whole part, multiply it to what? To 9, as we can see. That 9, so the answer will be multiplied to x. So this is what I'm trying to say. 9, open bracket, then open another one for the -3. So that's -3 to the exponent of what? Of 12. Then we're going to subtract the 1, close this bracket, over what? -3 minus 1. We subtract the 1 this time. So this was going to give us this whole value. But remember, there's what? There is x here. So whatever that you're going to have as your final answer, do not forget that there is x. So it is going to be multiplied to what? To x. So this is it. So we're going to obtain, as we saw on our sum, it is a negative. So that's -1,195,740 there. times what? Times x. In terms of what? In terms of x. We have got the sum of terms in that case. In terms of what? In terms of x. Summation is simply sum of terms. Use the corresponding SN formula of the what? Of the series provided. It's a geometric, so we know that. If it is arithmetic, therefore use the sum of terms for the what? For the arithmetic, this one, or you can use the Sn, n over 2 into a plus what? Into a plus l. Any corresponding part. So this is how these questions are given as. Let us consider another part of our question, which is 2.2. A quadratic sequence with the general term Tn. Here's the following properties. So there are some properties that we are given. T29, Tn minus Tn minus 1 is what? 3n minus 4. Determine the value of the first term, T1. All right, we do not know T1, and we must calculate that one, the first term of the quadratic sequence. All right, so this type of a question, guys, by just looking into this, I can see that there are so many ways of answering, so many ways, but I just want us to use the basics that we can have, the ones that we are used to. Remember that when you are given a quadratic sequence, we have got our terms, but so far we do not know these terms to say which one is which. But let's say our terms are given. This is T1, this is T2, this is T3, this is T4, and so on and so on. Let's say those are the terms of the quadratic. You were going to determine the first differences. I want you to understand something there. T2 minus T1. What does this tell us? T2 minus T1. T2 minus T1. This part is here. It's also here. It's also here. T4 minus T3 and so on. Those are your first differences. But in what it seems to be confusing, it is something that is direct because they told us about something familiar there. Tn minus Tn minus 1. This statement, guys, this statement here, are we seeing it is the same thing? If our n is 2, this will be n minus 1. It will be 2 minus 1. 2 minus 1 is what? It's 1. This is what they're trying to say. T3 minus T2. Let's consider that. T3 minus T2. What does it mean? If our n is 3, the other one is what? N minus 1. 3 minus 1 is what? Is 2. So this part here of these differences, the first differences, is the one that is represented by the statement 3n minus 1. So each and every case that you're going to have there, you must use the formula 3n minus 4. 3n minus 4. So what does it mean in actual sense? It means that the n is the one that is important here. This n minus 1, it is the n that you put here. So if we have got, let's say, T2 minus T1, our n is 2. This is n minus 1, this one. This is n minus 1. Our formula does not have n minus 1. Our formula is in terms of n. So meaning to say, for T2 minus T1, we are simply saying our answer is going to be given as 3 times n, our n, which is what? Which is 2. This is your n. So 3 times 2 minus what? Minus 4. That's the value for T2 minus T1. 3 times 2, that's 6. 6 minus 4, that's a 2. Or you can just use your calculator. So T2 minus T1, we have got its value. Because the answer there is what? Is 2 from the formula. So the same thing, T3 minus T2. When we say T3 minus T2, what is the value of n? What is the value of n? From the term that is starting there, n. So our n is 3. So we substitute 3 in place of n. 3 times 3 minus 4. That's 9 minus 4, which is going to give us what? 5. So the term T3 minus T2 was going to give us a 5. The same, guys, T4 minus what? T3. If we say T4 minus T3, n, this is n minus 1. Our n is what? 4. So in place of n, put a 4 there. 3 times 4 minus 4. So that was going to give us what? 12 minus 4, which is what? Which is 8. So this was going to give us 8. So from these, we obtained the first differences, guys, from a given statement. We obtained what? The first differences from that statement. This is how these questions can be given as. Remember your revision. This is what it means. So meaning to say, from these terms that we have, we can find the second difference because, guys, we have got our first differences. So this one is no longer important. Let us determine the second differences from there and see what's going to happen. This here, 5 minus 2, that's a 3. 8 minus 5, that's a 3. So as you can see, guys, we have got the common second what? Second difference, which is exactly what we want. We are used to this formality because we are simply going to take this. The second differences will be equal to what? To 2a. All right. The first term of the first differences is equal to what? 3a plus b. Our T1 now. Yes, it was supposed to be equal to a plus b plus c. But guys, we do not have that T1. We must solve. This is the one they are asking us. So the statement a plus b plus c, guys, is not going to work. We must find it. So let's use what we are given so far and find what we can find. From a and what and b, we can find them, those a and b, because 2a is equal to what? The second difference, 2a is equal to 3. Divide by 2 by 2. So a is what? 3 over 2. Let's move on to 3a plus b. It must be equal to what? 3a plus b must be equal to positive 2. With the value of a that we calculated, guys, we can even make b the subject. B is equal to 2 minus what? If we take this one to the other side, 3a. So we can simply substitute on this side. 3 times our a is what? 3 over 2. We can even do it this way so that we do not like have a lot of things to consider. You substitute, but it's still one and the same from what you are used to. So this was going to give us what? 2 minus 3 into what? 3 over 2. 3 over 2. So this was going to give us negative 5 over 2. Just like that. Since we cannot determine the value of c because we do not have T1, it is the one that we must calculate. Let's just substitute back to how it was supposed to look like. Remember our quadratic, Tn is equal to an squared plus bn plus c. So substituting this, it was going to be a 3 over 2n squared, our b negative 5 over 2n plus what? Plus c, where we do not have the value of c. If we had the value of c, it was going to be easier to calculate T1 because for T1, we know that n is equal to 1. You just have to substitute there. But we cannot do that because we do not have the value of what? We do not have the value of c. So there must be a statement given or that we can use to solve for c first. We must solve for c first. How is that possible? There is a statement that we are told about these terms, that one of the terms, which is T29, is equal to what? 1116. T29. So using that, it is a statement that we can actually work with to say from the T29, which is given as 1166, it means n is 29. So we're going to form an equation 1166 representing our Tn is equal to what? 3 over 2 times our n, which is 29. So that's 29 squared minus 5 over 2 times our n, which is what? Which is 29. In this case, plus what? Plus c. So we must solve for c from this equation. As we can see, guys, we can simplify these values. Let's see, guys, from the right hand side, simplifying this, it was going to give us 1189 plus c. So to find c, simply take this to the other side. It's going to be a negative, and that's 1166 minus 1189. So the difference there is what? Is a negative. So that was going to give us negative 23 as our value of c. Since we needed this here, substitute it back there. All right, so we've got our Tn from this c that we just calculated. Thus, we are going to have our Tn. So therefore, our Tn is given as 3 over 2n squared minus 5 over 2n plus our c, where our c is what? Negative 23. So we are going to put minus 23, which is easier now for us to determine the value of T1, because for T1, it simply tells us that n is 1. So therefore, T1 is equal to what? In place of n, you are going to put a 1 there. So this is 1 squared minus 5 over 2 times 1 minus 23. We substitute as it is. So you can even simplify from your calculator direct. This is 1, guys. So just use your calculator direct. You were going to obtain negative 24. Just like that. Negative 24 as our T1, the first term of the quadratic sequence. So you see, guys, revision is important because they will give us questions in different manners, in different ways. This is where our revision plays a role. Do as many questions as you can, You'll see that most of these questions will be a repetition. For someone who is revising, it will be a repetition. You see this question, the moment you see it, you know, okay, I'm going to attempt this one this way. So that is it. Let's move on to another question, which is question 3, where we are given, all right, this formality or layout we have got to answer 3.11. Show that f of x can be written as this. That's a hyperbola. All right, how can we show that? This one, there are so many ways, again, in order for you to simplify this type of a question. Your f of x is given as 2x plus 3 over what? Minus x minus 3. The first thing to consider is that our x plus 3 is what? This part. It is not in this manner. This is negative, negative. So what happened for us to get a positive x and a positive 3? We had to factor out a negative. So let's just do that before our long division. You can use long division, any concept that you understand. So to make this positive, we must factor out a negative so that it can be a positive. Negative divided by negative, that's a positive. Negative to negative, that's a positive. So this negative can be written on top. All right. And as it is written on top, it's going to be like this. It affects everything. So it'll be negative like this, 2x plus 3 over what? Over x plus 3. So it'll be negative times 2, which is negative 2x. Negative times 3, which is negative 3. Everything over what? X plus 3. We took the negative up, remember? But when we took it up, it affects every term. Using your long division, some of you guys are used to this. Anyway, that you understand, you still have your answer there. Let us just use long division. It's easier to apply this, guys, because you simply have to divide by what? By x plus 3. So it's x plus 3 into this. X plus 3 into this. So how do we divide? It's always first term to the first term minus 2x divided by what? Divided by x. This is going to give us what? A negative 2. So with the negative 2, we must multiply. So you divide, multiply back. Divide, multiply back, subtract. So we multiply back here to everything that we see here. The minus 2 multiplies everything. So this is it. As you are multiplying, it is going to be minus 2 multiplying everything. So minus 2 times x, minus 2x, minus 2 times positive 3. That's a negative 6. We subtract. So if we subtract here, minus 2x minus minus 2x, guys, this is going to cancel because it will be like this. Minus 2x plus 2x. That's a 0. Minus 3 minus minus 6. Minus 3 minus minus 6 is going to be a plus. So it's minus 3 plus 6, which is what? Which is a positive 3. So this is what we are going to get after subtraction because the x cancelled. We cannot divide 3 divided by x. It's impossible now because it's always first term to the first term. So you cannot have that division. So it means this is our remainder after our long division. So therefore, our f of x can be written as what? After dividing, this is what we obtained. We obtained a negative 2 and a remainder, which is positive what? Positive 3 over x plus 3, just like that. So as we can see exactly what we are given, only that the layout or the way that is presented, we started with this. We can even just rewrite f of x is equal to 3 over what? X plus 3 minus 2. This is what we are given. So there are so many ways. If there is any other way that you feel like applying or using, just use that. But at the end of the day, you must obtain the same answer that you're given. This is show that. So there's no way you must have your answer in that manner. If you are using any correct method or any correct way. Moving on to the other part of our question, which is 3.12. Hence, from that part, hence it's a continuation, guys. From that part, continue to determine the coordinates of what? The intercepts of f with the axis. So the intercepts with the axis, we're talking about the x and the y intercept, all right? So that's our 3.12, the intercepts. So in this case, we are having a continuation, like I said, from our f of x, this one. We can determine our intercepts, all right? So let us just have our intercepts calculated. That's 3.12. We're going to start with the x-intercepts, all right? Let's say intercepts, all right? So x-intercept first, intercept. In that case, y is supposed to be equal to what? To 0. You solve for x. Y is equal to 0, so solve for x. This is 3 over x plus 3 minus 2. So how can I solve? Take the 2 to the other side. It's going to be a positive 0 plus 2, which is 2 is equal to 3 over x plus what? X plus 3. How can I solve this? This is same as over 1. So we can simply cross multiply. The 2 multiplies everything. 2 times x, 2x, 2 times 3, positive 6. Or 2 into the bracket of x plus 3, where 2 expands everything, all right? This is equal to 1 times 3, which is 3. So solving for x, we are going to obtain what? Take the 6 to the other side. That will be a negative. So 2x is going to be equal to negative what? Negative 3. 3 minus 6, that's a negative 3. Divide by 2 by 2. We have got the x value. In that case, that's our x-intercept, minus 3 over 2 versus 0. The y value, remember that's a 0 there. So this is it. And for the y-intercept, we have got the same condition for letting one of the terms or one of the letters to be equal to 0. So this time it is x, which must be equal to 0 in order for us to have the y-intercept. So x is supposed to be equal to 0. So y is equal to what? 3 over what? In place of x, you put a 0 there. So that's 0 plus what? 0 plus 3 minus 2. So y is going to give us, at the end, if we simplify this, that was 1 minus 2, which is what? Negative 1. So that's it. We're going to have x is 0, y as negative 1. So this is our y-intercept, and this is our x-intercept, all right? So just like that, this is how we can have our questions. As you can see, it'll be something that is a little bit direct. We just have to be very careful on attempting your questions. So moving on to 3.13, they want us to sketch the graph of f, indicate the intercepts with both axes as well as the asymptotes. All right, as we know that we are dealing with a hyperbola, in that case, we can easily consider the issue or the condition of our asymptotes. That is the most important thing. That's the most important thing, actually. So 3.13, our asymptotes, it will be what? X is equal to minus 3. From that, x plus 3 is equal to 0. So x will be what? Negative 3. So this is the condition of the x minus 3, and the y value as what? As a negative 2. Those are our asymptotes. Remember, from the asymptotes, if our a from the f of x is equal to a over x minus p plus q, if this a is greater than 0, which is a positive, we are going to have our function this side of the asymptote and also this side from your asymptote. So the shape from our a, we've got the shape as well. So, and do not forget the intercepts, the x-intercept and the y-intercept that we calculated before. We are going to use those ones again. So this will be a direct, if you understand this, guys. Let us just have this x-intercept and y-intercept, just like that. So that is it. Knowing the shape, and this is going to be important, guys. All right, so let me just have it here, since we now know our intercepts and so on. So let me just try to have this here. All right, no problem. I cannot change it, but let me just even try, even here, it's fine. Let's try to just say this is our x-axis, y, and so on. So do not worry, guys, about this type of a graph. It's just a straightforward type of a graph that you're going to have. So let's say this is our y-axis, all right, somewhere here, and our x, because from those, from our asymptotes, we can see that they are more on the negative side. They are on the negative side compared to the positive. So do not worry about the positive side. All right, the positive side, there's nothing much that you're going to have. So this is negative 1, negative 2, negative 3, negative 4. Then going up, we're going to have 1, 2, 3, 4, negative 1, negative 2. So the y value is negative 2. So guys, I'm just gonna remove this one. But we saw, guys, our shape, how it is going to be or how it is going to look like. All right, so moving on to the asymptotes, x is what? Negative 3. So x is negative 3 at the point where x is negative 3. We must have a vertical line there. That's a vertical asymptote that we are having there. X is what? X is negative 3. Then y is negative 2. On the negative here, we're going to have an asymptote again for the y, which is y is equal to what? That will be Sorry for that. We're going to have y is equal to negative 3, negative 2. So these values, if you do not indicate them properly, guys, it is going to affect your graph. So you must have these ones properly given. Y is equal to negative 2. So we saw according to the shape, if our a is greater than 1, greater than 0, going to have the shape like this from our asymptotes. So this side, it tells us that there is no intercept with any axis, guys, on this side. So it's just going to be something like this, no intercept with the axis. But this side, we are not just going to draw, because as we can see, the curve that is going to be on this side must have an intercept with the x and also with the y. So what is the x-intercept? That is where we go back to those intercepts that we are given so that we can be able to indicate our x-intercept and y-intercept. So remember, from here we said our x-intercept is at what? Minus 3, 2, minus 1, 5. The y at what? At negative 1. So x minus 3, 5, minus 1, 5, I mean, minus 3 over 2, which is minus 1, 5, just in between minus 1 and minus 2. That's where we've got minus 1, 5. Then the y value is what? Negative 1. So that's our y-intercept, our x-intercept. With the shape that we expect to have for a hyperbola, we can sketch the other section of what? Of the graph, as there are two pieces on this graph. There are two pieces to be formed. So you're going to have the last piece this side passing through the x-intercept and y-intercept, but it is not supposed to pass through the asymptotes. Remember, it's not supposed to pass through the asymptotes, something like this. It tends to approach to the minus 2, but it won't reach the minus 2. So this is the other piece that you're going to have, but it must pass through the x-intercept, the y-intercept. So this is our f. You can indicate it this side. You can indicate it on this piece. It is up to you. So that is it. Our x is minus 3 as an asymptote. Our y is minus 2. We have indicated that. That was the most important thing to have on your graph. So with this, you are going to have full marks. So that is how they can ask these typical questions. Then on that part, after sketching, they wanted, all right, so we indicated everything here, guys, everything, all right, axes, asymptotes, all right. 3.14. On 3.14, they want us to determine the equation of the axis of symmetry of f, which is a decreasing function. Axis of symmetry, remember there is this one increasing and there's another one decreasing. So they want with one decreasing, negative gradient, a decreasing one, all right, which is a negative gradient. So where are we going to have our axis of symmetry? It is going to pass through the intersection of the asymptotes, where x is minus 3 and minus 2. Remember the concept, guys. If it was to be drawn, it was going to be something like this, with a negative gradient passing through the point of what? The asymptotes. Intersection of your asymptotes here, passing through that point where x is minus 3 and our y value is minus 2. And we do understand the equation, the general format. Remember, if you just know, guys, this we are done. Y is equal to minus x plus c. Always, always, this is not going to change. So since our gradient is a negative decreasing, negative gradient, y is equal to minus x plus c. To find the c, substitute what we have at the asymptotes, the minus 3, minus 2. We have got the x value because the line passes through that point. So you must use that point to determine the value of c. When y is minus 2, we substitute our x. Our x is what? Negative 3. So this is it. We can solve for c. Minus 2 is equal to minus minus positive. So to solve for c, we're going to take this to the other side. So it's minus 2 minus 3, which is what? Negative 5 is equal to c. So therefore, the equation representing the axis of symmetry with a negative gradient or as a decreasing function will be equal to what? Y is equal to minus x plus c, where our c is what? Negative what? Negative 5. They are going to ask such questions. Understand your questions, all right? In case that we are going to need this equation, okay, just be able to remember it, guys, all right? Let us consider the other part of our question, which was 3.15. Determine the value of values of x for which a, our f is decreasing. The function f is decreasing. This is our function f, guys. Where is it decreasing? The function f, as we can see, it's a decreasing function, guys. For these values, as you can see, here it's going to be going down. Here it's going to be going down. So that's a decreasing function throughout. So x is supposed to be real because we can notice that for this part, all right? So this is 3.15. For this part, from negative infinite up to this negative 3 of what? Of the asymptote. When our x is taken from negative infinite up to the point of what? The asymptote, of which it cannot reach that. The function is going to be decreasing, going down. Or from what? The negative 3 from the asymptote, that part. As we are going these values, as we are going more positive, our function is going to be decreasing. The values will be decreasing from that condition of what? Minus 3 up to the positive infinite, up to the endless values. So as a combined, we can see that for only one condition of the asymptote, x cannot be equal to what? To minus 3. So instead of us separating this, we can just easily say our x is not equal to what? Our x is, or our x is just, let's just have this one, is supposed to be a real number, but not equal to 3. Not equal to minus 3, I mean. As minus 3 is on the asymptote. X can be any value. For this function of f, it is already a decreasing function, but only on a condition that x cannot be equal to minus 3, because that's what? An asymptote. You have done. So that is, you could have just answered as this one on top or this way. Okay, so anyone, let us move on to another part. The value of values of x for which f of x is greater than or equal to 0. Which conditions are these where our function f of x is greater than 0? We must look into the graph. Where is it that our function f of x is above the x-axis? This is the meaning. So that's the B part there. When they say f of x is greater than or equal to 0, this is y is equal to 0, the x-axis. You compare it from that y is equal to 0 in the x-axis. So greater than or equal to 0 is something that is found above the x-axis. We must be above the x-axis. Above the x-axis. So do we have our f above the x-axis? Yes, we have it. If we check our f from here, from this here up to what? Up to minus 1,5. It is above the x-axis. The moment we move from minus 1,5, guys, it is now below the x-axis. We cannot take this part as that is below the x-axis. Above the y-axis, that is on top, I mean above the x-axis, y is equal to 0, above those values. So we are supposed to consider our x values from where? This piece only, from here, this region. What is the region? Remember, x cannot be equal to minus 3, as minus 3 is an asymptote. So x must be greater than minus 3. It cannot be, even though there's an equal to on your question, but x cannot be equal to minus 3. That's an asymptote. So it is limited for values that are greater than minus 3 up to what? Up to minus 1,5. where y is equal to 0 in that x-axis. So it is less than or equal to. There we can have the x value being equal to that minus 1 comma 5. Remember, the minus 1 comma 5 is the minus 3 over 2. So you can have it as minus 3 over 2 or what? Minus 1 comma 5. Anyone there. So this is it. For these values of x that we have there, our f of x is greater than or equal to 0. It is a positive value. It is above the x-axis. So you can interpret it graphically by looking into your graph, what is exactly happening. So if they said the conditions where it is below, when it is f of x is less than or equal, we are now considering below the what? The x-axis. So this will be interval from minus infinity up to what? Up to minus 3. Another one will be taken from what? Minus 1 comma 5 going up to positive infinity. It will be below the x-axis when it is less than or equal to 0. You must know what you're dealing with. So this is it. This is how these questions might be given as. So for 3.15, the way it was 3.15 A and B. So this is 3.15 A, which we had here. Then this is 3.15 B. Okay. So that is how these questions are given as we can see. It was our question. Right. There seems to be another part of our question 3. Let's hope it is not going to bring us back to this information that we are given. All right, it's another question on its own, which is now we have got a parabola this time. So we have got a sketch of a parabola this time, which is given as f, and the straight line gx, r and s are both, all right, the intercepts, x-intercepts here, this one and this one. So r is found on both f and what? And g. Okay. We are given the point P as the turning point of f. Then g has got the x-intercept of what? Of r there at what? At r, which is okay, no problem. No problem. From there, 3.21, you're being asked to calculate the coordinates of what? Of r. Let's see. If we had the equation of f, because we do not even have that one, they are even asking for that equation of the parabola. So there's no way we can actually deal with the parabola there. Let us just focus with what? The easier concept, which is the linear, the function, the straight line. From the straight line, because r passes on the what? On the straight line. It is part of the straight line. So we can use the straight line to answer this question, because r is also the x-intercept of r, as it is the x-intercept of what? Of g. Of f. It is the x-intercept of what? Of g. So that is what you can actually use. So 3.21, to determine the coordinates of r, in this case, we are going to use the gx. Remember, our gx is the graph of y is equal to 3x plus 6 as we are given. So r as the x-intercept, we do understand y is equal to 0. So use that condition. If y is equal to 0, what is the value of x? You solve 3x plus 6. Let us solve for x. 6 to the other side is going to be negative. So that's 0 minus 6, which is negative 6, is equal to 3x divided by 3 by 3. So x was going to give us what? Negative 2. So that's the x value. At r there is negative 2. So therefore our r is negative 2, 0. So this is it. Our r there is negative 2. So that's negative 2, 0 there. With this information, we can even determine that equation of the parabola they wanted here, guys, because okay, let's just find it. The equation of the parabola. We do not have the x-intercepts, all of them, but we can even determine those ones. But it's, guys, remember, there are formats that you use to determine the equation of a parabola. So it is up to you which one do you want to work with. Since I have a turning point, I can use the turning point format. A into x minus p squared is plus q. There is the equation that I can use for a basic one where there's a turning point. Yes, I can find this s because we know that this is symmetrical. So if this is minus half, it means same distance here is the same distance to that point. So you can even find the value of s because this is just like a mid ordinate. So you simply add minus 2 plus the x value there over what? Over 2. You must get minus half. So what is the x value? You can solve for that one. You can solve for that one. Let's see, times 2 times 2. That is going to give us here minus 2 plus x is equal to what? If we multiply by 2 here, that is going to give us negative 1. So x is equal to what? Minus 2 to the other side, x is equal to minus 1 plus 2, which is what? 1. So x here is 1. So that's the 0.10. You can even use that if you want. So I want you guys to use that and determine your equation. But in this case, we are assuming we do not have that. We just want to use what already is given. Why do we have to take that turning point, adjust it to give us another point? Why can't we just use it as it is? Because it is the format that is also part of your syllabus. Y is equal to A into X minus P, where P, Q is our turning point. What does it tell us? The turning point, when it is positive, here you put a negative. So if the value of x is a negative as what we are given, how do we substitute it here? It will be a positive. It changes. X changes. P minus P. So when it is minus already, it means this must be positive. All right, so it's going to be positive 1 over 2 squared plus the value of q, which is the y value as it is, which is 9. Just like that. So you have got a presentation, but in this presentation, we do not have the value of a. So where and how can we determine the value of a from any given point besides the turning point, anyone? So that's where we take advantage of what? This one, the R there, because R is a common point for both F and what? And G. We can use that. So from point R minus 2, 0. All right, let's use the point R there. From point R minus 2, 0, we've got the x value, the y value. Y is equal to what? To 0. So 0 is equal to a into our x, which is negative 2. So in place of x, we are going to substitute a negative 2. So that's negative 2 plus 1 over 2 squared plus what? Plus 9. We can solve for a as we have got an equation where a is the only unknown value. So solve for what? For a. 9 to the other side is going to be a negative, or you simply have to subtract a 9. So that's negative 9 is equal to, simplifying the right-hand side, that part inside of the bracket, that's negative 2 plus 1 over 2 like this. Then close the bracket and square it. So that was going to give us what? 9 over 4. So we're going to have 9 over 4a. To determine the value of a, simply divide by 9 over 4, guys. Or you can do your cross multiplication, this and that. It is in your hands. But do you see that this is simply 9 over 4? So it is simply minus 9 over what? We divide, all right, to the 9 over 4. You can just even open bracket and put it like this, 9 over 4, so that you can properly see. This is what? Negative 4. So a is equal to negative 4. Or like I said, you can cross multiply. It is up to you. This is 9 over 4x. This is 1. We cross multiply. Minus 9. 1 times 9 is 9x. Negative 9 times this, negative 36. We divide by 9. By 9, that will be negative 4. All right. This is a instead of what? Instead of x. So you obtain the same value of a, which is what? Negative 4. So therefore, this whole function representing our f of x will be given as what? In place of a, we have it negative what? Negative 4. So that's negative 4 into what? X plus 1 over 2. X plus 1 over 2 squared plus what? Plus 9. So there are so many ways, guys. You can use this one. If you expand it, you can even obtain the other format of a quadratic, which is the one that we could have used from these x-intercepts. Let's say we used the x-intercepts. Then we're going to consider f of x is equal to a into x minus x1, the x-intercept, x minus x2, the other. You expand this and that. Still, you are going to obtain same answers, but only that they are differently given, like their format. This is the turning point format from the turning point. You can work with that one from the turning point. So as we can see, these functions, graphs, it's all about revision, guys. Do more revision. On question number 4, we are given 4.1. The graph of the inverse of x is given as a square root of 3x for x is greater than or equal to 0 is drawn in the sketch below. So this is the graph of the inverse and passes through the point 3, 3. Okay? They gave us the graph of the inverse. From the graph of the inverse 4.11, determine the graph of f, the original function from the inverse. Guys, the inverse is the what? It was taken from the original function, isn't it? So if it was taken from the original function, therefore, it means the original function is the inverse of what? Is the inverse of the inverse. That is it. It is the inverse of the inverse. The original function is the inverse of this inverse that you see here. This is what I'm trying to say. So we can simply determine it because we have that. All right, remember. So that's 4.11. Our inverse function in terms of y is equal to, from our inverse function, y is equal to the square root of what? Of 3x. So to determine its inverse, when you determine the inverse of the inverse, you are finding the original function. So that's it. Find inverse. How do we find the inverse? Remember, we have to interchange x and y first. So that will be x is equal to the square root of 3y. After that, you make y the subject. Make y the subject. How can we make y the subject? Y is under the square root. We have to square to get rid of that. So that is square root and the square neutralizes. So 3y is equal to x squared. To find y, simply divide by what? By 3 by 3. So y is equal to x squared over 3. Right? Just like that. We can simply substitute whatever value that we want to make sure that this is exactly, to just confirm if it is exactly what we need. But we are limited for the values of x originally, so we can consider those x values as they were originally, that they are what? Greater than or equal to 0. So this will be our original function as our f of x, x squared over 3, for the condition that x must be greater than or equal to 0. Guys, it's just the inverse. The inverse of the inverse is the original function. The inverse of this original function is going to give us that inverse. If you do it, you're going to go back there. So we're just trying to play around with you there. So now they're saying, can we determine for which values of x will f of x be less than or equal to its inverse? Yes, we can solve that, but we can even just try to figure out. Let me check if there's any question about, there's no part that they need us to draw this and that. All right, no problem. We can even check this, guys, graphically, because we have got the inverse there. Remember the condition of the inverse to its original function. It is going to be drawn along the line y is equal to x. And in the line, y is equal to x, there's something about the point 33. The point 33 lies in the line y is equal to x. When x is 3, y is also 3. So meaning to say you are supposed to be careful there. The inverse, the mirror line of y is equal to x, the one that gives us the inverse function, was going to pass through the point 33 as well. It is part of what? It is part of our graph y is equal to x. It lies on that line y is equal to x. I just want you to see something. This is our line y is equal to x. Given this as the inverse, it follows that its original function is just a reflection along the line y is equal to x. So it was going to be something like this, the same thing, then it goes back like that. It was going to be like this. This is what you're going to get as your what? As your f of x. As we have got the inverse, this is our f. So the question here is asking us to say, what are the conditions that f of x is what? Less than or equal to its inverse? What are the conditions there? What are the conditions? This is our 4.12. All right, 4.12. What are the conditions that f of x must be less than to its inverse? Its inverse. So we just saved the two graphs are there. So f of x to be less than its inverse, we must consider where f of x is found below, when it is below what? Its inverse. So this, as you can see, our f of x is originally from its sketch, it is below. This one, it's above. The inverse is on top of f of x. So it is below for these values of x in within here, x, which is 3, and what? And 0. In within this interval, we can see that our f of x, guys, it is below its inverse. It is less than when it is like that, when it is found below another graph. So therefore, these are the conditions. X must be greater than or equal to 0. Since there's an equal to there, less than or equal to what? To 3. So 3 and 0, they are part of our solution. These are not a condition of asymptotes where you can say x cannot be equal to 0. No, x can be equal to 0. X can be equal to 3. So that is it. You see, they will be playing around with you guys. Just direct questions where you just need your diagram. Understanding your diagram can also make it easier in attempting these questions. That was 4.12. 4.2, we are given, consider g of x as 1 over 3 to the exponent of x. 4.21, determine the equation of its inverse in the form y is equal to the format. All right, how do I find the inverse of an exponential function? Just like what we have, if it is a linear function, whatever that you have, guys, y is equal to 1 over 3 to the exponent of x, just like what we had before. The first thing is to interchange x and what? X and y. So it means x is equal to 1 over 3 to the exponent of y. Then we make y the subject. Make y the subject. From which concept? Because there's an exponent there. Remember the concept from the logarithm of x in the base of b equal to y. It follows that this x can be written as b to the exponent of y, the base to the exponent of y. As we have got this condition, this is what we have here. X is equal to this. So it simply tells us that therefore log of what? Of x. Log of x. In the base of b, our b is the base. What is our base? 1 over 3. In the base of 1 over 3, it must give us y, which is our exponent here. So it must give us what? Y. Y is the subject, as we can see. So therefore, this is our inverse. Y is equal to the logarithm of x in the base of what? In the base of a third. Just like that. And these, remember, values of x, we are dealing with the logarithmic function, and the 1 over 3 as a base. Whenever there is a rational base like that, it means we are dealing with a decreasing what? A decreasing function. That logarithmic function is what? Is decreasing. So you must also understand that, because look here, they want you to draw it on 4.22. Draw the graph of the inverse of g, indicating any intercepts with axis, as well as one more point. There must be one more point on the graph. Can you draw that? It's a logarithmic, and I said this one is what is decreasing. So if you know, guys, what you are dealing with, it'll be easier, all right? It'll be easier. We are dealing with a log, and it's a decreasing function where we do understand it's going to be something like this, just like that. So in our case, we are done. So that is 4.22. So we are dealing with a log. I'm just going to have a sketch, guys, here. All right. Anyways, let's see. You can even just have this one. All right. And this other one here. So that is what you're going to have. And let's just try to adjust a little bit. So this is our y-axis and x-axis. So we can just have our main points on a logarithmic graph. What is important, guys, is the x-intercept. The x-intercept, remember, y is equal to 0. So in that case, it'll be like this. The logarithm of x in the base of a third is equal to 0. So the x value is supposed to be equal to what? A third to the exponent of what? Of 0, which is 1. You must know that, guys, it's going to pass through 1 from those graphs that we did before. It passes through what? Through 1. So it is a decreasing function. The rational number that we have on the base tells us that it's a decreasing function. So it's going to decrease like that. So that's a decreasing function. This is what you're going to have. So our values of x are limited. They must be greater than what? Greater than 0. For a logarithmic, guys, x must be greater than what? X must be greater than 0. So this is what you have. But they said there must be another point, one more point, because we need the axis as well as one more point. So one more point, which point can we use? We can even use 3. It is easier, guys, we have got 1 over 3. So use multiples of 3. 1 over 2, use multiples of 2. So for 1 over 3, we can use what? Multiples of 3. 3, 6, 9, and so on. All right. In fact, not just like multiples, but what can we say? We can say powers. In those powers of 3. 3 to the exponent of 1 to the exponent of 2 from the 0. Remember, 0 is this one. So let's say powers. If we say multiples, this will be like, say, what are you saying there? All right, the powers of 3. Any power of 3. So if you take that one and put it here, I want you to see any power of 3. We cannot use 0 because we used, guys, to the exponent of 0 is the one that gave us 1 here. All right? When our y is what? When our y is 0. So we got a 1. So any other one, we move on to 1. We can use 2, whatever that you want. So when the power is 2, it means our x is 9. When our power is 1, 3 to the exponent of 1, it means our x is 1. This is what I'm trying to say. In place of x, substitute its powers. So this is what I'm trying to say. Let's put 3 log in the base of what? 1 over 3. Then here, you put any power of 3 to the power of 1, to the power of 2, to the power of 3, any one. So here I'm just going to use 1. So 3 to the power of 1 is what? Is just 3. So it's just going to remain as it is. The answer is minus 1. So this is what I'm trying to say, if you understand me here. When x, because this is x, log x. So when x is 3, the y value representing the whole logarithm is what? Minus 1. So it's a point. X is 3 and y is what? Minus 1. So you could have used any power of 3, like this one. 3 squared is 9. So in place, you put a 9. As you can see, we've got minus 2. 3 to the power of 3 is what? 27. 3 to the power of 4 is 81. Any power of 3. You can get exact values. They are saying any one of your choice. So when x is 81, y is minus 4. Anyone. So I'm just going to use the first one, guys. When x is 3, we said y is what? Minus 1. So let's say this is 2, 3, and so on. Let's say this is 2, 3. So it means 3 on the graph is going to be 3 versus what? Minus 1. Remember, we said 3 minus 1. When x is 3, The answer is -1. So it's a point that you can indicate as well any one of your choice. Any one of your choice, as long you just use those powers of what? Powers of 3 and so on and so on. Like the graph of h, which is given as hx, is this, passes through the point -10, -2 versus 10. Calculate the value of a. All right, that's a direct question because you are given x and y there. So guys, this one was just a direct question. Y is equal to what? You substitute 10 is equal to a into 1 over 3 to the exponent of x. What is our x value? -2 plus 7. Guys, one of the direct questions in your mathematics, all right? So solve for what? For a. Take the 7 to the other side, it was going to be a -10 minus 7, which is 3 is equal to what? So that is 3. But as you have got this, simplify the right-hand side, all right? Remember, we took the 7, we subtracted it both sides, so it's no longer there. So the left-hand side is fine, it is 3. But the right-hand side, simplify that fraction. Use your calculator, guys. Don't worry about laws of exponents when it's like this. Use your calculator there. 1 over what? 1 over 2 is being raised to the exponent of a -2. Your calculator listens very much. So just use it. It can give you exact values. It is designed for that. So that was going to give us what? 9. So that's 9 times a, which is 9a. To solve for a, simply divide by what? By 9 by 9. This is going to cancel. So a was going to give us 1 over 3. That is 1 over 3 from there. So this is it. Then describe the translation. They already told us it's a translation from H to what? From H to G. From H. Which one is our H? H is the one that we just given, this one. So remember, we have got the value of A. So let's substitute that one and try to figure out what happened. 4.24. We want to transform from H to what? To G. H, A, we just calculated on H. We said our A is what? 1 over 3. So I'm going to substitute that in place of our HX. 1 over 3 in place of what? In place of A. So that's 1 over 3 into what? 1 over 3 to the exponent of x plus a 7. This one. I'm just rewriting this in simplest form with what we are given. Just substituting and try to figure out. So that's our hx. So what actually happened to get g, which is our g? Our g is this one. 1 over 3 to the exponent of x. That's our gx, remember? So these are the two graphs. I dealt with transformation as a separate topic, so make sure that you go through those videos that can actually help you guys to understand in a much better way what we are referring to here. Our gx is given as 1 over 3 to the exponent of x. So the question is, what happened from here to here? From this graph to this graph. As we can see, just a single 1 over 3 to the exponent of x. The 7 is not there. This and that. All right, let's figure out first. What is it that we can see here? We need to combine this one into a single 1 over 3. It is the same thing, same basis. Remember, when you're multiplying, you add the powers. This is the same as to the power of 1. So it is hx is equal to 1 over 3 to the exponent of x plus 1. Same basis, you're multiplying, you add exponents. So this is our hx. So what actually transpired from the positive 1 that was here, it's no longer there. It's just x. So what happened? We had to subtract a 1 from that one. It was like this. This is x plus 1. But we must obtain x. So there's something that happened on our x. There's something that happened on our x here. Something happened on our x. We had to substitute as x minus 1 so that this will be a minus 1. So it was x minus 1. So that when we have got x minus 1 plus the 1 that is originally there, minus 1 plus 1 is what? It's a 0. So you are left with x. So this is the transformation that we need. What happened in order for us to get this? On that x, we substituted it as x minus 1. So that when you put x minus 1 there in place of x, it will be like this, x minus 1 plus what? Plus 1. That cancels. So what does this transformation tell us, guys? F of x minus 1, I talked about this from our transformations. F of x minus a, horizontal shift, going where? To the right. Minus, it means to the right. So it is 1 unit to the right. This alone tells us we have got what? 1 unit to the right. This is what happened. So that it can neutralize to just give us x. What about the positive 7? It's no longer there. There is no 7 there. So what happened? We had to subtract the 7. 7 minus 7, that's a 0. To subtract, it means we are going down. We are affecting vertically the values of y. F of x minus a, our a is 7. We are going down 7 units down. So those are the two translations. As we are told that they are translations, so there are two of them combined together. So we have got from H to what? From H to G, that's a translation. That's a translation occurring there, a translation or a shift of 1 unit to the right, a shift or a translation of 1 unit to the what? To the right. But we saw that there is also 7 units going down and 7 down as we are going downwards. So it was a combination, two transformations combined. Translation 1 unit to the right, 7 units down. They are being combined together. So if you put those into this, guys, you are going to have your hx. This one. So that is how your transformation questions can be given but like I said, I described these transformations before. So just make sure you go through your questions in as much as you can. As you can see, it was having 3 marks and the whole of this question 4 having 15 marks out of this question. So as you can see, guys, they do ask these questions. They are going to really ask these questions. So you must be very careful in each sense of what topic. The idea of the topic, very, very important to be known. The idea of the topic to say, I have got this part. What exactly am I supposed to use or to apply? As we consider question number 5, where we are given 5.1, this is a continuation from what we have already done before. As we can see, guys, we are told that if 5 sine beta minus 4 is equal to 0 and the beta is taken in the interval from 90 to 270, determine without the use of a calculator and with the aid of what? A diagram. So they want us to have a diagram to answer this question, all right? So we are told about the angle beta. It must be in which interval? 90 to 270, as we have got our angles. These are positive angles in the anti-clockwise direction. That is going to be 0 degrees, 90 degrees, 180, 270, 360 degrees in an anti-clockwise direction. So 90 to 270, this is the interval that we are working with. So we are going to note, because one quadrant has to be used at the end. So we must now consider the sign that we have for the sign of beta. Is it positive or negative as a fraction, so that we can tell which quadrant exactly are we going to use. But so far, our answer is in these two quadrants. The diagram is left in these two quadrants according to what we're given there. So anyways, let us just try to figure out the ratio of the sign that we are going to have in that case where we are given 5. The sign of beta minus 4 is equal to 0. Let's solve for that sign of what? For the sign of beta. So we need to get rid of the negative 4, which is affecting the whole part there. So it's going to be a positive on the other side, or simply add a 4 to get rid of that. So 5 sine of beta is equal to 0 plus 4, which is 4. To determine the sine of beta, simply divide by what? By 5, both sides of your equation. So that was going to be positive 4 over 5, which tells us that the quadrant where sine is a positive, because we have got these two quadrants, guys. Which quadrant sine is positive? That is the second quadrant from the cast concept. Sine is in the second quadrant as what? As a positive. In this quadrant, our sign will be negative. So we do not want this to be negative. We want to be positive. So the second quadrant is going to be the best in order for us to represent the triangle that we are going to use to solve our problem. So like I said, in the second quadrant, this is what we're going to have, guys, as our triangle here. So it's going to be right angle triangle. Remember the sign as a ratio from our SOHCAHTOA concept that is opposite over hypotenuse. So we have got the opposite and the hypotenuse. So that's, just put this one as your angle beta. Do not have a problem with that. So that's your opposite, which is 4, hypotenuse, which is 5. So that's opposite, hypotenuse, and that's our adjacent. We do not have that. Let's calculate our adjacent, which represents the x values. All right, as we have got our x and y values. So thus we can determine. All right, I'm going to need this one. Let me just keep it. But you can even, guys, just use your Pythagorean triples. You can tell that this is what? -3. But anyways, if you do not understand that, it follows that r squared, our hypotenuse, is x squared plus y squared. So that's our r being 5, hypotenuse, is equal to x squared. We need the value for x given the y value of what? Of a positive 4. So that's it. We can take this to the other side. 5 squared minus 4 squared is equal to what? X squared. So this is going to give us 25 minus this. Then we're going to introduce the square root, of which you can just use it direct on our calculator here. The square root of what? 5 squared minus 4 squared. So that was going to give us 3. And the square root of any number is plus or minus, meaning to say we can have positive values of x, or we can have negative values of x. According to our diagram, the x has to be what? A negative value. So we are going to use negative this side. This is the negative from what? From the origin. So that's it. The diagram that you need to answer these questions that we are given here, we can simply use the diagram, as they said, with the aid of a diagram. 5.11, the cos of beta. So the cos of beta, as we have got our ratio, we can simply use this adjacent over hypotenuse. So that's 5.11. The cosine of beta is equal to the adjacent over hypotenuse. What is our adjacent? That's -3 over the hypotenuse, which is what? Which is 5. So we have got the cos of what? Beta. Just like that. Exactly the solution that you're going to get in any other way that you can use. So I want you to use any other way that you understand. You're going to have the same answer there. 5.12, the cos of 2 beta. They gave us these angles in terms of beta, not cos, not 2, like to have something like a 2 here. is just beta, sine beta. But that 2 now complicates everything. Remember, this can be taken from our identities where we have got double angle identities here. They are double angle identities for the cos of 2 alpha. The cos of 2 alpha can be written in any one of these 3 identities. So you are going to take any one of your choice because we have the sine, we have the cos, we just need to square it. You can take the first one, you can take any one of your choice, you're going to have the same answer there. All right, so as for me, guys, I'm just going to use the first one. But like I said, any one of the 3, you're going to obtain the same answer. So do that. If you do not obtain same answers, that means something is wrong. So cos 2 beta is going to be given as cos squared beta minus the sine squared of beta. If I use the first identity, you can use 2 cos squared of what? Of beta minus 1. You can use 1 minus 2 sine squared of what? Of beta. Any one of these 3 identities. So here, what does it mean? I just have to substitute because I have the cos of beta. I have that one. I have the cos of what? The cos of beta. I also have the sine of beta. So substitute, but do not forget to square the values as they are given with the square. So that is the condition. The cos of beta is what? Negative 3 over 5. Negative 3 over 5. But that must be squared minus the sine of beta. Considering what we are given here, the sine of beta is 4 over 5, but we must square it as it is sine squared. So that's 4 over 5 squared. So that is it. We can square this negative when squared becomes positive. So that's 9. 5 squared, which is what? 25. The 4, you square it. The 5, you square it. So 4 squared, the 16. 5 squared is 25. So as we can see, the denominators are the same. So simply subtract your numerators. 9 minus 16 over what? Over 25. That was going to give us negative 7 over what? Over 25. So this is the cos of what? Of 2 beta from the given identity cos squared beta minus sine squared beta. So like I said, any one of the 3 identities was going to work in order for us to have this one. All right, 5.13. We are given on 5.13 to determine the value of sine 3 beta. All right, so this one is going to have a lot of things. Let me just keep this cos 2 beta here. Negative 7 over 25. All right, let's just have it because we might need that value. We might need that one. Cos 2 beta is what we obtained, negative 7 over 25. Okay, let's just leave it as it is. So just like the previous case, we're going to try to expand the sine of 3 beta as we are given on question 5.13. The sine of what? 3 beta. All right, 3 can be expanded from 2 beta plus beta so that we form compound angle there. All right, let's just try to form a compound angle and see what's going to happen here. This is equal to the sine of what? 2 beta plus beta. This we do not have. We still have the original question. We haven't changed anything. What we just did is to just expand 3 beta there. So that we have got a compound angle identity, alpha plus beta concept, or x plus y. So what is the equivalent of that sign? Remember the sign from our identities, the sign of alpha. There is plus. We are dealing with a plus. So you need this one. Alpha plus beta is going to be sine alpha cos beta, cos alpha sine beta. That is the concept that you are given. So as we have got this one as sine 2 beta plus what? Plus beta, like that. So where we see the alpha, we put 2 beta there in place of alpha, just like that. The beta is just that beta as it is. So guys, it's just gonna remain as it is. So that is what you're going to have. Sine 2 beta, cos 2 beta, sine what? Sine beta, like that. So let us just use that one direct and substitute, guys, into what we have. As we can see, it is a direct identity, sine cos. So it is sine 2 cos, sine of 2 beta, cos beta. Then it changes here to a cos. It was a sine, it changes to a cos. So it's cos beta, cos 2 beta as it is here, sine of what? Sine of beta. These are referred as two separate angles. They are separate angles so far. So that is the condition. 2 beta, 2 beta. This is beta, this is beta. If you understand that, you're done. So with this, let us check what we have so far. From what we have expanded here, we calculated the cos of beta. It is there. The cos of 2 beta, we also calculated this one. It's there. The sine of beta is originally given from what we were given before. We have this one. The sine of beta, it was from what we were given. We have this. But what about the sine of 2 beta? We do not have it. So we can calculate it from the cos 2 beta there. We can even calculate it from there. Play around your Pythagorean identities in place of 2 beta. You can calculate that. Or if you do not want to have confusion, just replace it with its equivalent identity, because we understand this one is still under what? Our double angle identity for sine 2 alpha. Let's get back here. Double angle. Sine 2 alpha is what? 2 sine alpha cos alpha. So if it is beta, this is going to be beta, this is going to be beta. So it's going to be 2 sine beta cos beta, just like that. So we can expand it that way. So meaning to say, in place of sine 2 beta, it is going to be 2 sine beta cos what? Cos beta. So this is it. We have substituted with its equivalent identity with what we have, because we have got this sine and cos beta. We have these ones. But do not forget, everything is just going to remain as it is. There is what? Cos beta also there. Or you can just write as cos squared beta. All right. This one is cos 2 beta times the sine of what? The sine of beta. Just like that. With these guys, you can substitute as we have this, we have this, we have this, we have this, we have this. Everything is calculated or is given. So let us substitute. Sine of beta is what? 2 times the sine of beta is 4 over 5. So this is going to be 4 over 5 times the cos of beta, which we calculated. Cos beta is what? Minus 3 over 5. So you're going to multiply to minus 3 over 5. The cos beta is the same here, minus 3 over 5. All right, plus, so you're going to add sine of what? The cos of 2 beta, which is negative 7 over 25, the one that we calculated before. Negative 7 over 25 times what? The sine of beta. Remember, the sine of beta is 4 over 5. We substituted this one before. So that is it. Without using a calculator, you can see that this is direct, you can multiply. But here, guys, even if you use your calculator, there is no problem. Just multiply everything. That was going to give us 72 over 125. Plus and minus, that's a minus. 7 times 4, which is 28 over 25 times 5, 125. Same concept as before. As the denominators are the same, simply subtract or combine the numerators. 72 minus 28 over what? 125. That was going to give us 44. So this is 44 over what? 125. In a simplest form, we have managed to simplify the value of sine 3 beta, the one that we're given, by expanding it so that we can have compound angle identity. But in that compound angle, there is also double angle that we can expand. There was no need of expanding the cos 2 beta because we calculated it before on 5.12. But if we had not calculated that, then there was a need of us expanding it. So you see, these questions you just have to answer according to how it is given. Let us move on to another part of our question, which is 5.2. Simplify this for 6 marks. All right, that's our 5.2. We must simplify this part. So here I'm not going to waste time, guys, because we do understand this concept, reduction of angles, this and that. So angles can be reduced to give us acute angles. So I'm going to start with positive angles. I'm going to indicate positive angles in what? In blue. Remember the first quadrant, it is in terms of theta. Let us just put theta as it is here, theta. In the second quadrant, this is 180 degrees minus theta. This is 180 degrees plus theta. This is 360 degrees minus theta. I explained this in your grade 11 mathematics. So these are positive angles, which is also opposed with negative angles. All right. So let me just separate the diagrams instead of me using this on a single diagram, but you can just understand it here, guys. So these are positive angles. And for the negative angles, remember, negative angle starting with the fourth quadrant in the other direction. This is minus theta. This third quadrant will be given as theta minus 180. This is minus theta minus 180. This is theta minus 360 degrees. Those are negative angles. So they represent the same thing as positive angles as long it is in a certain quadrant, which is as long you know the quadrant, guys, like from the cast concept. As long you know the quadrant, to say I'm in the first quadrant, guys, as long you know that, you are done. So let's consider what we are given here. All right, so this one tends to just misbehave sometimes, but this is it. Let's see what you're given. The first one is sine of minus 180 minus theta. Minus 180 minus theta is a negative angle, this one. Minus theta minus 180, it is the same thing. It is a negative angle, which lies in the what? In the second quadrant. This is the quadrant for a sine. Sine is what? Is positive, remember. So that's going to be positive. Sine is positive. So it's going to be sine of what? The acute angle theta. Remember, reduction, we reduce to the acute angle theta. So that was a positive. Positive in terms of the trig of a sine. The tan 180 degrees minus theta, 180 minus theta is a positive. It's found on the positive angles, 180 degrees minus theta in the second quadrant. And that's the quadrant of a sine, not a tan. So a tan in this quadrant is a negative. So that's a negative there. So we are going to have negative tan of what? Of theta. So this is it. Then the cos of minus theta, that's a negative angle, minus theta, a negative angle found in the fourth quadrant, and that's the quadrant of a cos. Cos is positive, so it is going to change to a cos being a positive, just like that. Cos squared 90 degrees plus theta is no longer under our reduction. We are back to our core functions, all right? Remember in your grade 11, guys, cos 90 degrees plus theta, it's going to lie in the second quadrant. So it's a negative. Cos is negative in the second quadrant. So it takes the value of a sine with a negative. So that's negative what? Sine theta. But it is being what? Squared. It is being squared there. So it is going to be minus sine of theta squared. Revise all the basics of your trigonometry from your grade 11. I explained all this in a playlist, so you can go through that for your revision, all right? So these are taken from the sine 90 degrees minus theta, remember, which is equal to the cosine of theta, cos 90 degrees minus theta, which is equal to the sine of theta. Yes, that is, we can even have as a positive, say it's theta, it's 90 plus theta for cos. Cos is negative there, so it's negative sign. If it was a sine, because in the second quadrant, a sine is a positive, so that means when you take it to be written as a cos, it is just going to remain as cos of what? As cos theta, because we need sine is positive. Here it's negative, so it must be negative here. Here it's positive, it must be positive. That's the concept. All right. Anyways, this is grade 11. Like I said, it's better. We do go back to our videos for grade 11. We revise as much as we can. So with this, that's no longer useful. We just have to expand and simplify further. All right, so let's see what is limiting our question so far. There is a tan, which we do understand. Tan of x is sine of x over the cos of x. So that's sine of theta times a negative tan, that will be negative sine of theta over what? Cos of theta. So this is it, times the cos of what? The cos of theta here. In the denominator, there is a negative raised to an even power. It's going to be positive. You raise the sine to the power of 2. That's sine squared theta. So you're going to have positive, which is sine squared of theta plus the 3 sine squared plus 3 sine squared of theta. So that's it. We can simplify the numerator and so on and so on. As we have got a fraction, this is the same as over 1 over 1. So the cos and the cos going to cancel. So we are left with the product. This is 1 sine theta times minus sine theta is going to give us minus sine squared of theta. It was supposed to be minus sine squared of theta over 1. But guys, dividing by 1 is simply going to give us this as it is. There is no effect of that 1. All right. In the denominator, these are like terms, sine squared, under an addition we can add as we consider their coefficients. These two terms are exactly the same, so we can easily add their coefficients. 1 plus 3, which is what? 4. So that's 4 sine squared of theta. This here can be simplified as these two are exactly the same. They can cancel each other. So you'll be left with negative 1 in the numerator. Then in the denominator, that's 4 times 1, which is what? Which is 4. So that is how these questions can be given as. You have simplified. Sometimes they'll ask you like show that or prove that. They will give you this one with an answer to say your answer is supposed to be minus 1 over 4. It is just a simplification at the end of the day. The way that you're used to simplify. Maintain that. All right? Just have to maintain that. On 5.3, it is to prove, just like simplify, but there is an answer that we are given. So there we must choose one side to work with in order to show that it is equal to the other side. So that's our 5.3. I'm going to choose the left-hand side. For this left-hand side to be equal to the right-hand side, this is what we are going to prove. Our left-hand side given as 1 over 8 into what? 1 minus cos 4x. Guys, the moment we have got these 4x. But if we check also, there is a squared. The sine squared, cos squared, sine squared, cos squared. Let's figure out, because we are going to play around with our identities this time. Sine squared, cos squared under a product. All right, let's see one or two things here. The sine, the cos of 2 alpha gives us 3 identities. This one, there's a subtraction of terms, so we can even ignore it. The second one has got a sine squared, which can be related somewhere in terms of a sine back here. The third one, a cos, it's going to be difficult for us to relate it. So I'm just going to work with the second one. for this identity. It's going to be best, but anyone can actually work when you're expanding, because there are chances that we are going to work with the cos because of this 4 that we are seeing here. We can rewrite it as 2 times 4x. So it is just like cos 2 times beta, where our 4x represents beta. So this is what I'm trying to say. So you just have to figure out from those given identities and see, guys, how can you simplify. So that's it. Producing a double angle identity, that's going to be 2 times 2x. All right, why am I getting 4? 2 times 2, yeah, to get 4. 2 times 2x to get that 4. The mind now is getting tired, guys. I need to refresh and make sure that we're going to have another proper video that's going to help. So anyways, let us finish up and see what we are given here. So this is it, a double angle identity of the cos of 2 beta. From the 3 identities, now you must pick which one do you want to work with. So like I said, I'm going to prefer the second one. The reason being, I need a sign that I'm going to square, because the sign there can be written. Remember what we see here, there's a cos squared, there's this one, sine squared, cos squared. It cannot be obtained when you are subtracting like 1 minus 2 sine squared, or maybe 2 cos squared, 2 cos squared x minus 1. It cannot be obtained direct, but from the final answers that we have later on, we can figure it out. So when you are also taking those identities, also figure out which one can give us opportunities of getting what? Sine and a cos being squared. And this sine and a cos is somewhere. We can see it somewhere, sine and a cos. On sine what? 2 alpha. So let's just be playing with a sine, because it will be easier for us to have sine 2 alpha. So I'm just going to focus on a sine more than a cos. So I'm going to use a sine. I'm going to use a sine. Remember, it must be squared. So that will be, if this is 2 beta, take note, 2 beta, this will be minus 2 sine squared beta. All right? So our beta is the one that is affected. In our case, our beta is this one, the 2x. The 2x is representing our beta. It's 2 times b, 2 times beta here, this whole part. So our beta is what? 2x. So that was going to be cos 2 times 2x is going to be written as 1 minus 2 sine squared. The beta, this is our beta, this one, 2x. So as we can see, the sine squared 2x, it has something to bring us cos times, that sine times cos. So let's maintain this one and see. Even if you do not win, because these identities still, they'll bring you to the same thing. It's one identity, remember. So if it doesn't win with this one, you go back to the other one, it will bring you to the same thing. But anyways, let's test this one and see. If we put back it here, it's going to be 1 over 8 into what? 1 minus the whole thing here that we simplified. It gave us this. 1 minus 2 sine squared of 2x. So this is what we got, and we can simplify that. All right, so let's try to simplify this, or let me just leave it here so that you also see where this was taken from. All right, so let's try to simplify this, expanding the brackets. That was going to give us 1 minus, here it expands, so that's negative 1. It expands here, that's a positive 2 sine squared 2x. So 1 minus 1 cancels, you are left with this. All right, so you are going to be left with 1 over 8 into what? 2 sine squared of 2x. This is where we are. So let's figure out again another thing here. The sine of 2x, that is the one that I wanted, this one. Remember, always I was talking about this. This is the one that I wanted here. And it is exactly what we can see, the sine of 2x. Why this? Because it has something about a cos and a sine together combined. and that is going to be easier for us to use. So it is equal to what? 2 sine alpha cos alpha. So what does it mean in our case? It means that the sine of 2x here was going to be written as the sine of 2x. We are using x as what? As beta. Our x is beta. So that is what we have there. So sine of 2x is going to be 2 sine of x cos of x. This is for sine 2x. So when you're going to put it, do not forget to square it now. So it was going to be 1 over 8, 1 over 8 into what? The 2 is not affected. So it's 2 times the sine of 2x is the one that we are substituting here. The sine of 2x, which is 2 sine x cos of what? Of x. But it must be what? It must be squared. So there we must be very careful about this. We are going to square it. So this is it. We have substituted what represents the sine of 2x as its equivalent, 2 sine x cos x. But it was being what? Squared. So this is the square. Let's square it and see. By square, guys, you see, when you prove, also, you are not like working something new. You have the answer. So always figure out to say, what is the answer, the layout of the answer? There is a squared sign. So that is why we also need that. Because you are proving something that you already have the answer. So don't use something that is away from the answer. No. So let's square this one and see what we're going to have at the end. Okay, let's figure out 1 over 8. If we are to square, the 2 is not affected. It's out of the bracket. So it's 2 times 2 squared, which is what? Which is 4. Sine squared, everything is to be squared. The cos also has to be squared. So this is what you're going to get. This is a product. 2 times 2 is what? It's 8. So that's 8 sine squared x cos squared x. And if you multiply this, 1 over 8 times 8, that was going to cancel. And you remain with this sine squared x. Sine squared x times cos squared x. Exactly what our right-hand side is given as. This is exactly our right-hand side. Exactly our right-hand side. So we managed to prove that the right-hand side can be given that way. So if you have got any other way of proving this, the community section is there. You can send your picture on the community. Just go on your YouTube app. Then under the community, you can check that. Send a picture there on how you solved it. It can even help someone. The community is not just for asking questions to say, okay, can we do this question? No, it is also for you guys. If you have got any other idea that you feel like sharing with to someone, all right, by sharing that, you are helping someone because someone could maybe actually have worked in that way that you are using, but maybe just mistakenly had some errors along the way. That person can follow up, say, okay, I can use this one in this way. So let's do share on our community. Let's utilize it as a sharing platform. On question number 6, we were given 6.1, determine the general solution of these two that are equal. So here it is just a matter of understanding that a cos and a sine can be written in the same manner. These are from our grade 11 mathematics, remember? So you choose. Are you going to write a cos as a sine, or you're going to write a sine as a cos? So in my case, I'm going to change a sine to be written as a cos. So it means the cos of x minus 45 degrees is equal to, I'm going to change a sine to be written as a cos. How do I change sine x to be written as a cos? Remember, from our complementary, it's what? Cos 90 minus x. So if it is sine 2x, this is going to be cos 90 degrees minus 2x as well. So this is exactly what we are going to do. We can change a cos to be a sine. It is up to you. All right. With this, guys, you can find your general solutions. You do not need to solve anything. You just take one from the left hand side, equate to the right hand side. So we are going to say, since we are dealing with a general solution of a cos, guys, we do understand that a cos, its general solution, if you are dealing with the exact values of x that you're going to have, is it the y value? We are going to have the reference angle plus k times 360 degrees, or we can have it as where cos is positive according to our case. These are acute angles, so you're going to use the cast concept. The first one and this one, 360 degrees minus what? The reference angle. So it's going to be 360 degrees minus the reference angle. That's plus k 360, where k is supposed to be what? An integer. So this is it. So in our case, our x is taken from the left-hand side. Remember this, guys, from your grade 11. You take this one as your x. It is the one representing our x in this case. So what is now our reference angle? Our reference angle will be the other angle, which is on the other side of your equation, which is your 90 degrees minus x. So that is going to be our reference angle. So meaning to say the first solution for our general solution is x is equal to the reference angle, which is, our x, guys, is represented by what? By x minus 45. So that's our x. X is equal to, our reference angle is represented by what? 90 minus 2x. So that's it. Reference angle plus k times 360. So this was the first solution that you must have for all integers. So we can solve it. This one is not a problem, or let's just finish with the second one, then we just solve at once. So that's it. Or another one, from the 360 minus reference angle, our x is what? X minus 45. So x minus 45 degrees is equal to what? 360 minus the reference angle. So remember, this is it. So it's 360 degrees minus, what is our reference angle? We said 90 minus 2x. That is 90 degrees minus 2x. So this is what you're going to have as 360 degrees minus the reference angle. But do not forget to add k times 360. So let's solve the first one. We must solve for what? For x. So here you must solve until you obtain the value of x. So solve for what? For x. All right. So here, guys, this is just expanded by one of you. There's no effect on this one. I can even just remove this bracket. As we can see, guys, 90 minus 2x is not affected. So I'm going to take the minus 2x to the other side. So it's going to be x plus 2x, which is what? 3x. Then I take the minus 45 to the other side of the equation. So it's going to be positive there. 90 plus what? Plus 45. So it was going to give us 135. So that's 135 degrees. There we are not affected. So that's k times what? K times 360 degrees. To find x, we are affected by the 3. So you can divide by it. Divide by 3, divide by 3, just like that. So that's our general solution to have any value of x. 135 divided by 3, that's what? 45 degrees plus k times 360 divided by 3, which is 120 degrees. So this is what you were going to have for any value of k being what? An integer. Okay? So with this, we are done. With this, we are done. Let's figure out on this other part. So as they are two of them, the other one from 360, 360 minus reference angle. Remember, there's another solution there. So that's x minus 45 degrees is equal to expand the brackets using the negative. So it was going to be 360 negative times 90, negative 90, negative times 2x. That was going to be positive 2x. 360 minus 90 is what? That's 270. So that was going to give us 270. You can even just combine those two guys, all right? So that's 270 degrees plus what? Plus 2x. Plus k times what? 360 degrees. Collecting the like terms, just like the previous case, we can take this to the other side. It's going to be a negative x minus 2x, which is what? Which is minus x. So minus x is equal to, we take the minus 45 to the right-hand side, it was going to be a positive 270 plus 45. Plus what? 45. So that was going to give us 315 degrees plus k times 360 degrees. So to find the value of x, we have to get rid of what is affecting our x, which is a negative. This is negative x, not x. The general solution is for x, not minus. So we must get rid of the negative there. Divide by -1 each and every term of our general solution. That's our x can be written as negative 315 degrees plus and minus, that's minus k times what? 360 degrees. So this is as a negative angle. This, we are given it as a negative angle. Remember, when you're referring to negative angles, minus 315 is something like this. This is minus 315. It's a negative angle. But it's the same as what? It is the same as this angle taken from the same point to here in the anti-clockwise direction, which is 360 minus 315, which is what? 45 degrees. They are equal. These two angles, they are equal in value. Take this angle of 45 and minus 315. Use any trigonometric, any trig ratio that you want. Is it the sine of this, sine of this? They are equal. Cos of this is equal to cos of this. Tan of this is equal to tan of that. They are equal. That is to show you that those two angles are equal or they are the same. So in place of this, to avoid negative angles, I'm going to use what? The positive angle corresponding to that. The minus 360, guys, is always positive. That one is for any completed cycle. It's going to change and just go back to the positive as we decided to work with positive angles. So this is it. We can try and substitute our corresponding values in our case and find the exact values. But in our case, it was not about those. It was just the general solution. So that was the case. Just the general solution. All right. So this is what you're going to have, just like that. You just have to be very careful in your simplification. All right. So that is what we had. That is what we had here. So I'm just going to take it here. Or we have got x, which is equal to what? 45 degrees plus k times 360. For both conditions, our k must be an integer. All right. Then we are later given a statement on 6.2 that in this diagram, our values were taken from minus 180 to 180, representing two graphs, f of x and gx. Are we seeing that there's something about these two graphs, guys, if we consider before? Are we seeing that 6.1, it was about cos x minus 45. 6.2, cos x minus 45. Guys, this is the same function, I mean the same trigonometric graphs that we have been working with. Cos x minus 45, it is this one. Sine 2x, it is this one. So when it is like this, be very careful. They will refer most of the things from what you had before. So this is it, guys. Anyway, That's our f, and the graph of what? The graph of what? Of gx. So our gx and our f here, it is given from minus 180 to 180, like that, all right? So that is it, the graph of f, like this. This is what we have. This is our f, all right? This is our f, and the remaining one being for what? Being the graph of g. So this is our g, all right, like this. All right, no problem. So that is what we're given. Then the two graphs intersect at B, C, and D. Point B, C, and D. That's point of intersection, point of intersection, point of intersection. All right. A minimum point on G at C. C. All right. So it is the minimum point on what? On G. Guys, this is G here. Or A. Okay, A, guys. Now I'm saying like a minimum. So A is right. This one, yeah. Now it makes sense. Oh, guys, it was like, what is happening? It was not even making sense. But anyways, now it makes sense. A is the minimum turning point. And another thing, in terms of the angles, you are going to notice something about the graph of what? Cos x minus 45. It means we were using the interval of 45 degrees, 45, 45, 45. Like at this condition, if you check, it'll be 45, 45, like that, in that manner. Like this will be 45 plus 45, that's 90. 90 plus 45 is what? It's 135. 135 plus 45 is 18. Even in the other manner, minus 45 degrees, minus 90 degrees, minus 135 degrees. Those ones are intervals taken from what? The graph of a cos, by understanding that phase angle concept. I mean, like the angle that is affected in terms of the shift that happened on our graph. But anyways, the graph shifted from its original presentation from the graph of a cos. We do understand that the graph of a cos was supposed to be something like this, but it shifted as we have got the minus 45. It means we shifted 45 degrees to the what? To the right. It shifted to the right, horizontally to the right. So instead of us being at 0, we are going to be at 45, like that, like that. So it was just a shift that happened. Anyways, that is it. The interpretation of what you're given there. 6.21, determine or write down the period of what? The period of G. So the period of G can be determined by looking into the graph of our G. This is our G. As we know that the period is when it completes a full cycle. Guys, if we are to consider, it is actually completing a cycle, because this is what we have, guys. This one is going to be something like this here, going like that. So we can see that at 45 degrees going this side, it is a half of the graph and another half of the graph on the other side. Or we can say there is a half cycle which is from minus 180 up to what? Up to 0. Then from that is 0 to the other one, we are taking what? A half cycle. So it is going to complete the whole cycle in 360 degrees. Nothing has changed. The completed cycle, to say the graph is having this shape the way that it was, a complete cycle. It is still maintaining that, are we seeing? But only that it is just like an upside down. But it's 360 degrees, it will be completed in within the angle of 360 degrees. So meaning to say that's our period. The period is not affected on the graph of what? On the graph of G. The graph of cos is not affected. 6.22, write down the coordinates of A, the point A. So the point A is at minus 135, as I was saying, minus 45, this and that. So guys, this is minus 135. It lies on what? It lies on the graph of G, where x is minus 135. So we can simply substitute in the graph of G, x is minus 135. So the 6.22, the coordinate of the point A, x is minus 135 degrees. So what about the y value? You substitute, since it lies on G. So you substitute on gx. Cos, in place of x, you put minus 135. Minus what? Minus 45. What is the value that you are going to have? So that's cos minus 135 minus 45. So that is it. We're going to have what? Minus 1. So the y value is negative 1. So as a point x versus y is minus 1. So that is it. We have got the point A. So this is A, and part B, they wanted us to have the point B. All right. So B, if we check now on B, all right, let's see where our B is. Our B is this part of the intersection of the two graphs, where the two graphs intersect. It's not a condition that is clear like here at minus 135 or at 45 or at 135 like this one. It is not clear at B and at D. These ones are not clear. So how do we solve for these ones? Remember, guys, these two graphs, F and G, were taken from where? From 6.1. What is it that you are solving on 6.1? You are solving that these two are equal. And this is the condition that we understand for the point of intersection. At the point of intersection, the two graphs are equal. The graph of gx is equal to the graph of what? To the graph of f of x. So you were going to solve, but remember, you already solved this one in 6.31. I mean in 6.1. So you're not going now to resolve this. Now you take your gx, no, guys. Already we solved this. So these are the ones. At point D, at point C, but at point C advantage, we know the value is already there. It is for B and D. These ones, use the solutions that you already have previously on 6.1. So where exactly are we expecting this solution? That's 0 there. On our x, we are expect this is on the negative side. So our answer must be a negative from the solutions, the general solutions here. Our answer is supposed to be on the negative. So we can even test which one can be our best answer there from our k, as it represents integers. All right, let's use the first one. For k is equal to 0, remember we're going to go to minus 1, minus 2, and so on. Or 1, 2, and so on. We cannot use a 0. If k is 0, it's going to be 0 plus 45, which is 45. So 45 degrees is that one that I was showing you guys here. So 45 degrees is this one. So let's use negative values there. So we're going to try minus 1. Let's use a negative. In place of k, substitute minus 1. So if we substitute minus 1 in place of k here, it was going to be x is equal to 45 degrees plus our k is minus 1. So that's minus 1 times 120, which is 45 minus what? 45 minus 120. What do we get from here? 45 minus 120 is minus 75. Does this make sense? Does this make sense that our x is minus 75 there? Let's see. This is minus 45 minus 90. Exactly. Minus 75 can be here. So this makes a lot of sense. So this is minus 75 degrees. At this point, we can find the value of y since we have got the x value. So at B, our x is what? Minus 75. So we must determine the y value from where? Remember, this is the point of intersection. So you can substitute the x value in any one of these two, in f of x or in what? In gx, whatever that you want. So as for me, I'm just going to use the gx. Remember, in gx, it is cos of x minus 45 degrees, and our x is what? Minus 75. Put minus 75 there. Simplify on your calculator. So this is what? Cos minus 75 minus what? 45, like this. So that was going to give us minus 1 over 2. So this is negative 1 over 2. That's the y value corresponding there, minus 1 over 2. So we've got the point B. It was a continuation from question 6.1. Critical values that you had as a general solution are the ones that we need, thereby substituting the value of k and see which one is going to be like that, like that. So for a negative value, that's minus 75. So you see, guys, these questions will be direct. Just have to be careful. With the point B, let us see another part of our question. Use the graphs. Work with your graphs. Use those graphs to determine the values of x in this interval from 0 to 180, where f of x over gx is what? Is less than 0. Guys, we are told where to work from. We are not looking into the left-hand side. No, we are working from 0. The y-axis is our limit. From 0 going this side, where is it that we are going to have that condition that we are given in the interval from 0 to 180? What will be the condition that f of x over what? Over gx must be less than 0. What does it tell us here? It simply tells us that our answer must be a negative. For this to exist, less than 0, that's a negative. So to obtain a negative, it's either f of x is positive. By that time, gx will be negative, or f of x will be negative. By that time, gx is supposed to be positive for us to get a negative. So this is what we need. From 0, guys, going the right side, because we are given that x must be taken from 0 to 180 in within. That's why I'm not showing you guys the left side so that we do not have confusion. So I'm just going to focus with that from 0 here. So at 0, we can see that, all right, the one that is in this is our f, the g is the one on top, this is our f here. So from 0, both graphs are in the positive, they are above the x-axis. You compare them from the x-axis. So both they are above from 0 up to 45. Both are above the x-axis. At 45 degrees, still they are above, as we can see, they are above the x-axis up to 90 degrees. From 0, 45 degrees, 90 degrees. These two graphs, they are above the x-axis. But the moment we reach 90 degrees here, look what is happening on f. F is now in the negative region. F is in the negative region from 90 degrees here. Whereas our G is in the what? In the positive, still on top. So this is what we want. One is negative, another one is positive. Up to 135. If we look properly here, at 135 degrees, at 135 degrees, we must be very careful there. All right? From 90 degrees, F is in the negative region, whereas G is in the positive, up to 135. So this region, we need it because one has to be positive, another one negative. But the moment we move from 130, let's move on from 130. From 135 degrees up to D, a point of intersection, which we do not know the value of x. But from this, we can even solve just like what we had before, or we can even figure out from this one to say, how was the difference from the 90 degrees? That was 90 minus 75 is what? 20 something or 15. 90 minus 75, there's a difference of what? 15. So the same thing there, 180 minus 15. That's what, that's 165 degrees that we are going to have. There is a 165 degree at D there, even though we are not going to talk about this for now, but it is important because it is part of our solutions. We could have obtained this 165 if we were substituting, like I said before. Here we have to substitute, remember, k is equal to 0, we're going to get 45. So when k is 1, if you substitute a 1 here, it was going to be 120 plus. It was going to give us that value. So from that solution, we were going to have the exact solution, guys. All right. So here, guys, you see everything just stopped. Let me see. Let me see. How can I bring back my page? My page here. So in this case, everything, guys, actually just resetted. So, but we saw that we were at what? The 90 degrees and this one at 135. So that is the condition that you're actually going to work with. It's only that now you see this thing of explaining a lot of things, guys. Now it ended up losing my information, and here I was saying this was gonna give us 165 degrees, which you can get from that interpretation of our general solution. X is 45 plus k times 120. When k is 1, you add that one, you put this one, you obtain 120 times this plus this one. So it was going to give us 165, or you just do the way that I've just explained before, because it is in within 180. But that cannot give us a solution here because this will be in the negative, this will be in the negative. So this side is totally out. From 0 degrees up to 90 degrees, this one is also totally out because they are both in the positive. So the only region that is left where one is positive and another one is negative is from minus 90 to 130, meaning to say here also 90 degrees to 135. I mean, this is going to be like this. One of these will be what? Will be positive. One of these, gx, will be positive. Whereas f at that moment is what? Is negative. So this is positive, this is negative. So that is the condition, guys, that you're going to use. So that's our 6.23 is everything. Just, guys, let me just rewrite. They gave us like this. It's less than 0. There is no equal to, so we're not going to have equal to on our answer. So x must be greater than 90 degrees, but the same x must be less than what? Less than 135 degrees in within. Remember, they told us limited from 0 to 180. We are not going to use anything on the negative. All right, so that is it. Those are the x values that you are going to expect to have to get a negative answer there. All right, so that's 6.1, 6.23. Then let's consider the other part of our question, which is now 6.24. Solve for x from the same interval. Okay, but I want us to look into this. We're going to see something, show all your working. From 0 to 180, just like this one. But guys, let's just figure out what happened there. There is something that they're just playing around with us, which is important for you to could have noted there. Sine of 2x is greater than or equal to 1 over the square root of 2. Then we have got cos x plus the sine of x. What are they trying to hide from us, guys? There's nothing that they are going to give us which is new. And there's nothing that they are going to give us which is new. Everything will be taken from those sine x and what? Sine 2x and the gx, which is cos x minus 45, the ones that we had in the first on the first part there. But they're hiding something. Sine 2x is properly given. So they are hiding that cos x minus 45. How are they hiding this? I want us to see. Remember the value of cos 45 from our special angles. Cos 45 is the same as sine 45. Isn't it the one that they gave us here? 1 over square root of 2. You see, guys, knowing those by head. 1 over square root of 2 is cos 45. Yes, our calculator gives us as a simplified value square root of 2 over 2. Where was this one taken from? 1 over square root of 2. From our special angles. So here they're just trying to hide something in place of this 1 over square root of 2. This one. It can be a cos, it can be a sine. So if you were to simplify this, 1 over square root of 2 times cos 45 plus, we multiply here by 1 over square root of 2, so it's 1 over square root of 2, the sine of x. You are going to notice that it is the identity, this one, guys, for what? Cos x minus 45. So for us to have this one, remember, it's supposed to be cos 45, cos x, sine what? Sine 45, sine x. This is what you're given. So the moment you see that this is cos x, cos 45, cos x, sine 45, sine x, you know this is exactly cos x minus 45. Remember, when there's a negative, it changes to a plus. They are hiding that. So for someone who could have seen this, you are done, because you see, okay, this is exactly what represents my what? My cos of what? X minus 45 degrees. So in our case, it will be, since, guys, you see what is happening here? It's 45x. You can start with x so that you don't have confusion. X cos 45. I want to maintain this one. I don't want to change it to be cos 45 minus x. But if you want, you can even change, because there's no difference in actual sense. You can even have it, all right, as 45 minus x. It is still one and the same thing if you have it that way. But remember here, what does it mean? Here it means, let me write down, cos x cos 45. There's no change. There's no difference, plus, because I want to maintain this one thing here. Sine x, sine what? 45. So that you can understand x, 45, 45. So this is cos x minus 45, just like that. So if you see that it is exactly the same thing here that we had before, x minus 45 sine 2x, they were hiding it from you. They are just saying on question 6.22, can you compare these two graphs from 0 to 180? Can you compare where is it that sine 2x is greater than this? Sine 2x representing what? The graph of f of x. Where is it that f of x is greater than or equal to cos x minus 45, which is the graph of what? Which is the graph of gx. This is what they are simply asking you, guys. They are playing around with you in exam. They want to play around with you guys. From 0 to 180, we are comparing from 0 to 180. This one is a straight comparison. How do we check this one? Where f of x is greater than gx, we need where f of x, where is it above, on top of gx? Where is it? So let's figure out from 0 to 180. Remember, we say this is 135, 165, 180, and so on. So where is it that our f is above gx? All right, this is our f here. Let's figure out, let's just redo that part. Our f, this one, this is our f. This is our f. All this, as we can see on our f, up to the point D, it is below the graph of G. As you can see, the graph of G is the one that is ruling. Oh, here it is the one on top. All this up to the point D. From D going this side, we now see the graph of G down below that one of G. But all this here, guys, check. This is f of x, this one. All this up to the point D, our f of x is below, not above. It starts to be on top here. This one, it's now above. From what? From the point D. where our x is 165. This is where it is now on top. From that x up to where? Up to 180, because we are given from 0 to 180. So we are limited that our x, yes, it can be greater than 165 degrees or equal to that. But it cannot exceed the 180. It must be less than or equal to 180. Why? That's an interval given from this interval. Guys, there are so many conditions where we have this f of x on top of gx. If we go back here, we can even trace, but we cannot use the negative side. But there was a condition where our f of x was on top. If we check here, continue with our f of x, we can see that from the point B, here our f of x here is on top. It is above. But we cannot use anything on the negative region, as our solution is stating that we are dealing from 0 to 180. Answer the question. Exam is not about what you've been taught in class. No. Exam is answering the mind of the examiner. What does the examiner wants you to attempt the question? In which manner? So I said before, for you to understand this, do revise as many questions as you can for you to be able to know the mind of the examiner. How do they ask these questions? It's all about revision. Do revise as many questions. Then you figure out, okay, these people, they just repeat the same thing. It's just a repetition throughout. Do revise. So these are the possible values of x where our f of x is greater than or equal to gx, where f of x is above gx, from the interval that we are given from 0 to 180, as we consider from 0 to 180, only from 0 to 180. Do revise. Don't be surprised in exam by new questions that you never expected. It's all about revision. If you revise, then there's nothing that will be new. All questions will be just as you have done them before. So let us give ourselves proper time, guys, where we do not understand. The community section is there. Let us communicate on the community section, or the comment section. We can just also communicate on the comment section so that we can assist each other on our revisions towards the exams that are ahead of time.